in general, not in any real context, but the slope of the slope, right? Up till now, didn't I mention this? Here, it's over here. I must have mentioned it. Here's the original function that's listed, or even if that's just a simpler version of this. But up till now, we've called this the derivative, but we're going to call it the first derivative. I think I mentioned to you. As soon as you have a second of something, then you got to call the first one first. And then the third derivative, and the fourth, and the fifth. You can talk about all those in practical purposes in real context. You don't get usually very far past the second derivative of something. The best context to put it in is something you're familiar with, which is if you have some function for position, like a function that is distance as a function of time, which you do in physics all the time. The derivative of that, the slope of that, right? If you have a graph that looks like that, the slope of that graph, if this is d versus t, as in, say, if this is in meters and this is in seconds, what's the slope of that graph represent? Velocity, right? Velocity is going to be, this is going to be, let's put the units here instead of that. The units here are meters. This is going to be meters per second, right? Every time you find the derivative, you do a per something. It's the rate of change. If we do the slope of that now, if we do the slope of this function, like let's say we made a velocity graph. If you graph the velocity here, what's the slope of that graph give you? The acceleration, right? Acceleration is going to be meters per second, or you simplify that to what? It's like meters per second every second, right? How fast is your slope changing? Every second, how many meters per second are you gaining or losing, right? Meters per second, but they like to write it as meters per second squared, just so you don't have all these horizontal or diagonal slashes like that. It's if I'm not sure how well you understand that before, but like talking about a projectile, what's the acceleration due to gravity? 9.8, negative 9.8 if you're talking about down being the negative direction. Negative 9.8 meters per second squared. All that means is that if you throw something up in the air and let it fall, okay, or drop it off the side of a building or something. What? Okay, fine. You don't want me to throw that? Okay. If you throw something up in the air and let it fall, it's, or if you drop it from here, how is its speed changing? What's it? It starts from zero and it starts to increase, right? Because it's being accelerated by gravity. Its speed is changing roughly 10 meters per second every second, right? Every second it's gaining roughly 10 meters per second. If you drop something off a building, after a second it's going to be going about 10 meters per second, right? It's gaining that much, okay? That's what its acceleration is. This is the second derivative. This is the first derivative, if that is the original function. There's other contexts. Basically, any function you can write, now that you know this concept in general, if you can write the derivative, this gives you the rate of change of whatever this function is. So it isn't just that you know from before that the slope of a position graph is velocity and so on. Now you're going to understand that the derivative of any function is the rate of change of that function. If you have some function that gives you the amount of money a company has made or something or other, right? If you have a function for dollars compared to time or something like that, I don't know. If you had something dollars and this was years, the derivative of that would give you, what would the units of the derivative of that be? Like what would the slope of this graph be? I don't know what the graph looks like. Something. What are the... Well, if this is the amount of money they have at any time here, what's the slope of this mean? It's easier if you think about this as like their bank account. What's the slope of this represent? Like right there, what is it saying? It's what? What's happening to their amount of money at that point? Going up. And then what's happening to their amount of money here? It's going down, right? The derivative is the rate of change. The derivative would be in dollars per year, right? That would be the rate of change. You could talk about the instantaneous rate of change. At this given moment right here, everybody's panicking because it's going way down, right? Whereas at this given time, it's going up, so everybody's happy, right? The rate of change of something is just whatever the units you're using. If you have a function that's dollars as a function of years, the slope is dollars per year. If you talked about the second derivative, it's maybe hard to think about, but it's how fast is this rate changing? From here to here, it goes from going up to going down pretty drastically, right? The second derivative would be, what would the second derivative be there? What's happening to the slope? The slope goes from really positive, 0, really negative. What would the second derivative there? Would it be positive, negative, or 0? In here, in this range in here. What's happening to the slope of this graph? It's decreasing for sure, right? It's positive, then it's less positive, then it's negative. The slope is going down there. The rate of change is going down. The second derivative would be quite negative. Just like if your velocity is decreasing, you have a negative acceleration. Anyways, for finding second derivatives, it's in a general context, it's just take the derivative and then take the derivative again, right? Which is what I did over there. That's what that is. After, you can put one little tick mark, 2 tick marks, 3, and then you just put a number in brackets. But you don't talk about the fourth derivative very often or beyond. You should probably notice something when you're dealing with polynomials, what happens. The last couple questions I put in here are just finding equations of a tangent line. Remember that the slope of the tangent line is the derivative. If you do the derivative of this, you get the slope of the tangent line. So if you want the equation of the tangent line at a certain point, you need two things. You need slope at that point, and you need to realize it passes through that point, right? To come up with an equation, you need a point, and you need the slope. Well, the point's right there, and the slope you can find by doing the derivative. So you can come up with the equation. I would like you to do that one and then check it on your calculator. Remember that you can put the actual function in, and then there's that draw tangent line. So you can draw the tangent line, it'll spit out the equation. Use that as a check. Do it first analytically by finding the derivative of this. Horizontal tangents. You can probably think about what happens here, right? Finding horizontal tangents, or in other words, where the slope is 0, or where the derivative is 0. You can find this by finding the derivative. Find y prime, then do what? Then sub in 0, right? Okay, and then solve for x, and it'll give you some values, right? Like if you come up with a derivative of this and then say it equals 0. Think about it in terms of the velocity as well. Like you could do that. If you're launching this bouncy ball up in the air, right? If you want to know, if you have a function for the position of this thing and you want to know when is it at its maximum height, you can use the horizontal, like you can say when is its velocity 0. You can use the derivative to find that top point. Okay? And I'm sure you can do that. And then after that, this is obviously not going to, this is not going to work for us, is it? Is this going to work? November 10th? Not next day, right? That seems kind of early. How about we just leave this like this for now? We'll fix it. We'll do it after. Can you work on finishing those questions right there? And since last time, I think I left you with this. Last time we did this. It's so long ago now, I sort of forget. But one today is finish this. Finish all of this. Number 2 is start 3.4. 3.4 is set up. There's a bunch of fill in the blanks at the beginning. You could start to fill in some of those blanks through discussion with somebody else, probably. And then 3 is, well, you're going to run out of time before we get to any number 3. So do that, please.